Hello everybody, today I'm going to present you a piece of code that is written in PureScript, which is a purely functional programming language which compiles to JavaScript, which means that it can be run in the front end or the back end. This piece of code is also part of a new pet project that I'm developing to find friends to play League of Legends. Which is a video game, so to find friends to play video games. This code is split in three parts. Oh well, two parts actually. Some type declarations right here and the actual execution here. So I'm going to go from top to bottom, okay? So first we have the first type declaration, which is the board state. So I have a board and said board has a state. And the state is an object which has four keys, four properties. In this case, in PureScript, this is not called an object, this is called a record. And the record has a left side, which is the name of the properties that it holds. And in the right side, followed by these two dots here, two columns here, it's the array. It's the array. What am I saying? It's the types. Here are the types. I hope that you probably got that before that I said it. So in this case, the type of the user entries is an array of board entry. The type of the board entries, it's same type. The filters is a set of filter, which the set, which is a data structure that also exists in JavaScript. There is like an array with only unique values, so you already know that one. And then you have the user, which is a data structure that's called maybe. It's a maybe of user. All of this is just one data structure. It's like maybe, it's like a generic, and it takes a value. The same with the set, it takes a value. The same with the array, it takes a value. Like it takes this type, take this type, which means this type is a generic type. And the maybe is the same as an array or a set is a container. And as an array contains a collection of values, and a set contains a unique collection of values, the maybe contains a value that may or may not exist, that may be nothing or just a value. So this is the state. This is the infinite representation of the state right here. And what I'm going to do is that I'm going to write this. Let's see, this is like a reducer for a reduced store, okay? So this is like a function that is going to take an event, okay? It's going to take a previous state and it's going to return a new state. So to model the events that this update function is going to take, I'm going to write this new keyword here. This doesn't exist in JavaScript, this doesn't exist in TypeScript, but the method does exist in TypeScript in some form. This is, as you might see by these lines here, this is a union. This is a discriminated union. Here is called a tag union in the case of PureScript. These tag unions are different from the ones that are in TypeScript in the sense that these ones have the tags explicitly declared here, like the syntax. In the syntax, you have to write the types here explicitly, and then you write the values they may or may not hold to the right of them. So, for example, the event init doesn't hold any value, it's just the event. In this case, this tag user change hold a value, which is of the type of maybe user. The user board entries change hold a type of an array of board entry. Me filter take also doesn't hold any value, and tier filter change hold a value of type string. This can be represented in TypeScript if you write an object and in that object you have a property which is a string, and then you say you have a union of multiple objects which all of them have the same property which can be called like key or kind or something like that, and that's a string that you write, and it has different values. So that will help the TypeScript compiler to promote that as a tag union and be able to make case analysis to discriminate if it is one object or another. In the case of PureScript and other functional programming languages, they prefer the tag version, which means that you tag the value that you're trying to represent, which is more easier to read as well. But kudos to TypeScript, which is just trying to represent what JavaScript is doing already. So here we go to the update state. In the update state, I say, okay, I take 2 arguments and return a third value here. So the 2 arguments that I take are events and preview. And I'm going to do this thing that is a pattern matching, which is a case analysis, like is case event off. So this is like saying switch event in JavaScript, okay? But the pattern matching in PureScript and other functional programming languages is like a switch case in steroids. Like you are able to express more through the pattern matching expression than you're able to express in a switch case in the case of JavaScript. For example, here, as the same way of a switch case, in the left side you will have the cases. You have these cases, and in the right side, followed by this line here, by this arrow here, you will have whatever is going to be executed. Okay, if the case holds. So I'm going to go case by case. So first you have the init case, which is going to return the previous value. So basically it does nothing. Then you have the user change event. And this is the case, okay? And this case, which is very interesting here, is that I can do some nested pattern matching and match on different constructors of other data structures. The maybe constructor is actually a union of 2 constructors, nothing, which holds no value, and just, which holds 1 value. So I can actually pattern match it here and the structure and say, if the value of the user is actually nothing, then return the previous state and change these properties on the previous state. So for the case of the user, assign the new user, which is where this came from here. This syntax means bind to the character u the value that is here. So u will be, let's say, a maybe user, which will be here a maybe user as well. So it checks. Okay, perfect. Now the user entries is going to be empty. I'm going to explain empty in just a second. And the filters is going to be, as I said, it was a set, right? So I'm going to perform an operation on the filters, which is the delete operation. So take the previous filters, delete the main filter. Okay, so that's one case, but pattern matching is rigorously, so it is exhaustive, and you have to provide all the cases. It's like if you had slin very well configured, and it warns you every time that you're missing a case in a switch statement, but this case in the pattern matching is like nested, so forever it enters and tries to see, hey, did you miss something? Are you missing something? So every time that we do this partial pattern matching, because it's matching on one way that the user might be nothing, then we have to pattern match what happens when it's adjust. So what happens if we actually have a user value? So what I'm saying here is, in this case, the way that I decided to write it is, okay, giving the event user change, bind the variable u to this next nested pair matching, and the nested pair matching, I'm saying if the user is just whatever, I don't care where's the actual value, then return preview and modify the user property and assign the user that is coming, which means if the user change, this whole object just boop, assign it there. If I used the value here, like if I binded a variable here and assign it here, it won't compile because the user property here is of the maybe user, of the container of maybe user, not the user itself. So it won't compile. I will have to rebox it because if this is unboxing, then I will have to rebox it. So I don't want to unbox and rebox. So what I'm doing is binding to a variable, returning the variable, and just pair matching. So I'm not unboxing, I'm just pair matching. I'm not unboxing because I'm not binding this variable, because this syntax means just discard whatever value is here and just focus yourself on checking the form of the data structure that is being passed through the event. Okay, so these two cases here are the full case analysis for the user change. Now I'm going to repeat the same, but in a different way. When I get a user board entries change, I may get the entries, but I don't want to, I can do also pair matching in this way, but I can also apply what is called a word, that is like an if statement, that whatever is on the, I put a pipe operator here, and whatever is on the right side has to return true. It's like a function that is going to be evaluated. It has to return true in order for this case to actually execute. So in this case, I say user board entries change, given the entries, bind the entries to the variable entries, and the guard says if the entries is null, and this null here is not a variable, this null here is actually a function. The function null checks for empty values in entries. And to express and to combine these two things, these two ideas together, entries, as we said, is an array of board entry. So it can be empty. So in functional programming languages, there are something that they are called classes, and there is a class hierarchy, but they are not like object classes. They are more like interfaces, in the sense that they don't hold any value. Each data structure has to implement some functions in order to be of a certain class. And in this case, the arrays implement one class that it means that the value, the data structure, has an empty value. So what empty does is a generalization through any kind of data structure. There is a monoid, which is that is a data structure which has an empty value. Are you going to execute and provide the empty value for whatever data structure goes here? So this is not this is like a function without parameters because I'm not giving anything, like I'm not giving any value. This is just inferring what kind of data structure goes here, which is an array of t, of board entries in this case, and he's going to say, okay, so return the empty version of that, which is an array without values, a collection without values. And in here is saying the same. If this is a collection of entry values, and if so, then execute this thing here. Return the previous state with this properties change. User entries is going to be to the new entries, so you are going to overwrite this one here. And in the filters, you're going to delete mine filter. And if, as we learned before, if we have a case that may not execute, we have to provide another case that always executes. So in that case, the other case is the user board entries without any guard, which means that if it is a user board entries change event, and this case doesn't hold, then it's going to fall here all the time. And the only thing that it's going to do is to override the user entries with the new entries. We have the me-filter toggle, which is going to return the previous state, and it's going to override the filters. And what it's going to do is that it's going to toggle on the filters set the my value. So toggle is a very interesting function that exists in the functions for set. And toggle, what it does is, if a value is in a set, then it's going to remove it. But if it isn't present, then it's going to add it. Okay. Now the tier filter change is a little bit more complex. What it's doing is, every time the tier filter change event is received, I'm going to delete any tier filter, and then I'm going to add the new tier filter that came here. So in this case, the filter is going to be overridden, and I say, okay, so get the previous filter from the previous state, get the filter value, pipette, this is a new operator called pipe, which means it's going to take this value and it's going to apply it to this function. And this is the function called filter. Filter here is the same as an array filter, but for sets, which means that if you provide me a function, I'm going to, for each value on set, I'm going to evaluate this function, and whatever returns true, I'm going to return a new set with only the cases that return true. So here I do another case analysis, because in the case of filter, it is also a target union. And in this case, I'm saying, do a case analysis on the value, and I'm saying this implicitly because I'm using again this wildcard here that is actually transforming this in a function, saying, without having me to specify the body of a function which takes a value and put that value here and then provides this, just like in this case, I make this function, I have this event, I put the event here, and I made a case. Instead of doing that, I just do a wildcard, and it's the same. This now is a function which takes one value, which has to be of the kind of filter, and it does a pattern matching on it. And all of this is inferred. As you see, I don't type it at all. And I say, okay, if the form of that filter is of type tier, discard the value and return false, which means that every tier is going to be deleted. And if it is whatever other value, which this is another form of the wildcard, then return true. So basically this filter is going to filter every tier. Now this filter, as you said in the toggle, we have the value, and then we have the filter, we have the set that this function is going to operate in. In the delete, we also have a value, and we have the set. Now this filter also needs a value, but we're not providing the value, because actually in PureScript, every function just takes one value, and we can make partial functions all the time, because every function is just a function nest in another function. If the function, for example, in this case, I take two values, in PureScript, this is actually two functions, but it looks like one because of syntax, but it's actually two functions. It's one function that takes event and another function that takes preview. So every function can be a partial function. A partial in the sense that I'm just giving it one of two arguments, or one of n arguments, or m arguments, like not all arguments. So it's half a function, a partial function. So this function says, when you provide me with a set I'm going to execute, okay? And I'm saying then this new operator here is going to apply this function and this function together, okay? It's a new operator. And this new operator is compose. It's actually compose. Compose flipped. But what it's saying is, I have a function on the left and I have a function on the right. And now these two functions are going to be just one function. And when I get given one value, which is going to be previous filters, because that's what the pipe does, I'm going to get that value, apply to the function on the left, and then the value of the function on the left, I'm going to pass it to the function on the right, and that's what I'm going to return. So this is a combinator, same as pipe, it's another combinator. Function combinators. And this is the strength of functional programming language. They have very useful for combinators. Okay, now the last combinator is insert. So I insert a tier of the value that was given to me. And the last case is very simple. If I get a board entries change, just override the board entries with the new entries. So this is the function. Is crucial for the homepage of the new pet toy, the new pet app that I am developing. I hope that you like the walkthrough. And it was a lot of syntax, but I hope that you got some interest in PureScript. If you have any question about PureScript, feel free to ask. If you have any question about JavaScript, feel free to ask. If you have any question about TypeScript, feel free to ask. You find PureScript to be, as you see, maybe it is a little bit strange. These ads here, these wildcards here. In this case, the wildcard is used in 3 different versions. Here it means whatever, here it means discard, here it means make a function, then you have this compose operator, and then you have this pipe operator, and then you have this data keep. That may be a little bit intimidating, but actually the syntax is very succinct, don't you think? Like expressing this reducer in JavaScript will have been much more lines of code. It will have been much more terse to read, much more nested to read, more prone to errors. But in the case of PureScript, which is actually compiled and statically tab checked, this code is much more secure. Like it gives much more confidence in that is right, and it's also much more smaller in the sense that we don't have to write things that are not necessary. So there is not much of repetition here, because we have very powerful operators, and that's what functional programming is all about. So I hope this small taste of functional programming was to your liking. If you want to know more about my new application, please follow along. I'm going to be posting more things of this new pet toy. I haven't released it yet, but I hope to release quite soon my beta or like my MVP for you to try if you play League of Legends. If you play any other game, let me know. Maybe I will also make a finder for that video game as well. But right now I'm focused on finding people to play League of Legends. So see you and have a nice day.